Hello, so today we are going to be sketching the bonding molecular orbitals of acetonitrile. So its molecular formula will be CH3CN. As you can see, I have wrote that up top right here. So now the next step is what we have to do is we have to draw the Lewis structure of this molecule. This will help us determine the electron geometry and what type of bonds go into this. We'll go over that. So the first carbon will have 3 bonds to a hydrogen. Now our carbon to carbon will be a single bond, but the carbon to nitrogen will have a triple bond and 1 lone pair on nitrogen. This is nitrogen's happy state. All carbons, they are also happy. They have their 4 bonds, no lone pairs, and hydrogens are happy. Now I'm going to split this up into 2 so it'll be easier. So this first electron geometry will be tetrahedral. How I know this is the 4 bonds that are bonded to carbon with no lone pairs. This will be known as tetrahedral. Its molecular shape, tetrahedral. Now the carbon to nitrogen, its electron geometry will be linear. This is known because the carbon to nitrogen, this triple bond right here counts as 1 bond. And remember, nitrogen, we cannot forget that lone pair. So that counts as 2, which indicates linear. Now, so tetrahedral, what this means will be sp3. This will be its hybridization. This is known, that's just how it is. The tetrahedral geometry indicates sp3. Hybridization of a linear geometry will be sp. Now that we have written that down, these are very key informations before we start sketching the bonding molecular orbitals. Now, in a single bond, this is important, it's what's called 1 sigma bond. Now, in a double bond, there's 1 sigma, 1 pi, but that's not relevant to us right now. And next, in a triple bond, we have 1 sigma bond, but this time we have 2 pi bonds. So if we kind of split it into 2, so technically 3 minus 1, so 2 on that triple bond are pi, and the last one will be sigma. Now that we have the basics down, we can start drawing. So we want to just place our first carbon down. So here's this carbon. Now, the first orbital that we can draw is the first sp3 orbital. The first sp3 orbital that will be attached to the next following carbon. So this will be S3. Oh, I just drew it wrong. Here, let me just fix it. So think of it as a flower petal. So the C is like the bulb of the flower. You want the pointed part away or on C. So yeah, just draw it like this, and that will be our first sp3 orbital. And then this one, now this is tricky. This will be an sp3. Now moving on to nitrogen, we have since the whole thing is linear, it'll be sp orbital overlapped. Now the reason why the second carbon, never mind, I'm gonna draw this first. So here I'm just drawing the sp3s, and these little circles just indicate that there is a hydrogen. So the other 3 single bonds also are sp3 since the whole thing is sp3. Now, what I'm labeling here, I'm just labeling all the sp3s in this compound. But what I was talking about earlier before I got kind of sidetracked, the second carbon will be sp, because if you look from the carbon to carbon, you have a single bond, but there's that triple bond that counts as 2, which is linear. Same thing with carbon nitrogen, it'll be sp. Now we cannot forget the lone pairs, because we just have to indicate that there are lone pairs. You want to draw a little orbital for it too, but inside you won't write anything, you'll just put that 1 lone pair in there. There we go. Now what we want to do is, because the reason why the sigma and 2 pi bonds is very important, we have to indicate that in this drawing. So what we're going to do, because it is included in the carbon nitrogen, we are going to draw our first set of parallel pi bonds. By doing this, we want to do it on the carbon, the second carbon, and the nitrogen. And they have to be as identical as possible. And we're going to fill in either the top or the bottom. It doesn't matter which one we fill in, but there we go. It just has to be parallel and identical. Now, here we're going to draw the second set of pi bonds. This will be what is known as PZ on our x and y axis. We do the same thing. It must be identical to each other. There we go. Color in the same one. So this will be, the orange is our PZ axis. So pi z also we can indicate like that. And now we can label this as our py because this is on the y-axis. Now our x-axis are where our orbitals are. So here I am just labeling what we got. So we got an sp3 overlapping in sp with our first carbon to carbon. Now with our carbon to nitrogen we have an sp-sp. And that should be that. So we have, and then on our outside where we have our bonds to the 3 hydrogens will just be 3 sp3s. That again is also due to the fact that it's tetrahedral. So this is our sketch.